but the combination of the three, in essence, describe this picture. Questions to hear? Velocity, change in position over change in time. Acceleration, change in velocity over change in time. What is the change in acceleration over the change in time? Let's just keep going.
This is not where the serial names come in, right?
Next step.
Okay.
Jerk. Yeah, this is the jerk. Change in jerk over the change in time.
Snap.
Change in snap over the change in time.
Crackle.
Change in crackle over the change in time.
Pop.
And that's as far as they went. Those, and I probably mentioned in the video, jerk is an American term. There are a couple other terms that are sometimes used. The snap, crackle, and pop, I think is basically American, and it has been in 2 published papers at this point. So, not universally accepted yet.
Or useful.
Yes, that too. I should track down the paper to find out why it went that route as opposed to some other route.
For fun.
And quite possibly. All right, one other bit here is that when you've got the change in position over change in time like that, if we're talking a noticeable change in time, such as you've got an object sliding up and down the hill, and I'm looking at change in time, that is taking place over a measurable amount of time. This actually is the average velocity. This actually is the average acceleration, and so on. If I want the instantaneous velocity, I need to do an infinitesimally small change in time. Who's at calculus, or in calculus now? Just 3 of you. Got 1, 2, got 2. And Matthew, was that a partial raise?
Yeah.
Okay. Technically, the instantaneous velocity is you let the change in time become infinitesimally small. So mathematically, you'd write it as the limit as the change in time goes to 0 of delta x over delta t. Now, all that's well and good. If you had calculus, you're doing the first derivative. If you haven't had calculus, what do? Well, we simplify things. We don't go with too many times when you have to use it, but graphically, if I have my position versus time graph, and that's my position versus time graph, if I want to find the velocity here, I have to find the slope of the tangent line. And when I mean my tangent line, it's a line that just basically skirts this curve and touches at that single point. So the slope at this point is just the slope of this tangent line. The slope of this would be the instantaneous velocity. If I wanted to know the average velocity at that point, well, I'm just drawing a triangle from where I began to where I ended. Basically, it's the slope of that line. That would be my average velocity. If I'm over here, I have a positive average velocity, because my average velocity would be the change in position over the change in time. My instantaneous velocity is negative, because that's a negative slope. We will explore this in more detail, not this Friday, but the Friday after. Fun will be had by all. All right, questions here before I satisfy, I think, the desires of everyone in here of an equation, something more than just this. So let's do it. All right, I got 3 minutes. I'm going to now start the derivation of the cake formulas. Cake, I am the only one who will refer to that, or potentially some of anyone who's had me before. I refer them as the cake formulas, and yes, there is sort of a repetition since E stands for equation, but constant acceleration, kinematic equations. So when I make reference to the cake formulas, I'm talking about these equations I'm about to derive. We will get through at least the first one. I'm starting out with acceleration is the change in velocity over the change in time. Since acceleration is constant, thus the CA, since acceleration is constant, it's the instantaneous value as well as the overall value. Instead of delta t, I'm just going to set initial time equal to 0, so I'm just going to now make this acceleration is equal to the change in velocity over time. Multiply both sides by time, I get acceleration times time is the change in velocity, which is final, minus the initial. I add the initial velocity to both sides. And what I'm left with is my final velocity is equal to my initial velocity plus acceleration times time. Yeah, I know, it's earth-shattering. This right here is the first of the cake formulas. It's the first one because it's the one I derived first. Newton's laws are set up so that Newton's first law is the same in every textbook, Newton's second law is the same in every textbook, third law, etc. These formulas, traditionally it's the first one derived, but it doesn't have to be. So, cake formula number 1, VF equals VI plus AD. Now, I was going to go into the next one, but it really requires more time to do the setup. So we'll end it right there. And the fact that we are on today's Wednesday, so Mondays, and we actually have school, we will go into the others. It's sort of like a teaser, cliffhanger of what are the other 3 formulas.
That's what I was asking also about.